All right, welcome back. This is day 3 of your note packet. This is page 13. All right, so just a little bit of review. A radian is the measure of a central angle, so we call it theta. This is just like an x or something that intercepts an arc, s for the variable. So the arc of the circle, so a piece of it, equal to in length to the radius of the circle. Alright, so remember the formula for the measure of a central angle. When I started doing that stuff, it was S over R. So this formula can also be manipulated. I can multiply both sides by R, I get the S by itself. The S, so the arc, is equal to theta times the radius. Right, but one thing to remember to know is that when you always do this, theta, the angle, is always in radians. So if we have to could do a conversion, pi over 180, so we talked about from Friday, then do the conversion. All right, after that, this is really what day 3 is about, just using these formulas and working backwards and forwards with them. So S equals theta R, or S equals R theta is a pretty common one. So start working with it. So find the radian measure of the central angle, so that means find theta of a circle, a radius of 15 inches, and that intercepts an arc of length 4 inches, so S. So the formula we are using is S equals R theta. You plug in your numbers. Let's see. Four inches equals 15 inches times theta. Get the theta by itself, divide by 15, divided by 15. The central angle is 4 over 15. 4/15. Okay, so that's all you're doing. Since it is a central angle, we would say radians. So at some point pi was already multiplied into that, so don't worry about adding pi. Do not change anything, leave it alone. Alright, so find a different one. So find the radian measure of a central angle. So we're looking for theta of a circle with radius is equal to 12, and it intercepts an arc of length 6 pi centimeters. Now, one thing on this is, like, I'm not going to try to confuse you with the, different measures, centimeters and centimeters. I wouldn't change it to like centimeters and inches, just make you do that conversion and then another thing. That's not the idea of this. Okay, so the formula S equals R theta. Plug in your numbers. I have 6 pi equals 12 times theta. Divide by 12, divide by 12. Simplify your fractions always. You get 1 pi over 2 is theta. So pi over 2 radians. All right, number 3, find the length of the arc of a circle, radius of 9, so R is 9. Intercept a central angle of 60 degrees, so watch out because it's in degree measures. So the formula we are still using is S equals R theta. Now this is a special kind of where the star comes in. In the formula above, theta needs to be in radians. We always do these with radians. So to convert from degrees to radians, we do like we did last week. So 60 degrees times pi over 180. So you get pi over 3. Alright, so to find the arc, S equals R theta. So that's what, 9 times pi over 3. So that's 9 pi over 3, or 3 pi. And that's going to be, so the arc is, sorry, label. All right, so I'm going to skip number 4 because it's kind of the same thing. You have, when you're looking at a picture here, this would be theta, this would be r. You're just plugging in the numbers. So now I'm going to skip down to number 5 because it's a little bit different. So again, you have theta here. So an arc is subtended by central angle measuring pi over 3 radians. What fraction of the circumference is the arc? All right, so the formula for arc length is S equals r theta. So far I'm going to plug in my theta, and so I get r times pi over 3. Now, we know the circumference formula is 2 pi r. So I want the arc length as a fraction of the circumference. So I'm literally just making these two into a fraction. Literally. So r times pi over 3 divided by 2 pi r. Okay, so the nice thing you can see right away, the r's will cancel out, which it's intended to do. Really, you're just seeing how much of a fraction out of 2 pi is pi over 3. So right now I have pi over 3 divided by 2 pi. When we are dividing fractions, I take the bottom one, I make it into a fraction, and I flip it. So this is really pi over 3 times 1 over 2 pi. Okay, or you can see that you have a pi on top, pi on the bottom. Pi should cancel out because I'm looking for just the fraction. Pi should not be in it anymore. And you can take 1/3 and divide by 2, and that, or you can take this and multiply the tops. I get 1 over 6. So pi over 3 versus a whole circle is 1/6 of an entire circle. Okay, that's it. Thanks. Bye.